So these are padding, and then boxes. Well, this is nothing new. These are the boxes that we obtain here. And then I'm going to clone it because we're going to display those boxes in just a moment. I'm going to call this same function, but now in addition to this, I'm going to plot for this 640 by 640 the boxes that we have calculated coming from the NumMax expression. And what we want to do here is scale this bounding box from this size image to this one, and then eventually to the original size image. So the way we do that is the following. Given that we know how much we've padded, and now we want to reduce the padding so that we can convert it back to this size image, what we're doing is, well, the padding was in the height dimension, and the height dimension, given that we have x, y, x, y, well, in the x dimension, if you look at this coordinate and then this coordinate, with respect to this image, the x of this top corner has not changed. Neither here nor here. The x has not been changed. So in that case, we add that padding, which is padding of 0. But then the y component, here we had this padding. So the y is coming top, bottom. This is the y. But in order to get the same y for this unpadded image, well, we have to subtract the padding. We have to subtract 80. Because this is 80 and this is 80. We don't care about this part because the top left coordinate is our 0, 0. So this y component minus 80 will be this point in this box. And then the same one for this one. This y minus 80 will allow us to plot it in this 480 by 640 image. And this is what this is doing here, the y padding. So we perform this operation, and I'll just save this into another variable so that we can display it as well. And bbox1 will be this box right here. And then the last thing that we do is, given that from this 480 by 640 to this 768 by 1024, there is a 0.625 ratio difference. So by dividing x and y by that 0.625 gain, in order to correlate this bounding box from these dimensions to these dimensions. And this is what this operation is doing right here. Okay, and this box, after some processing, which in our case is not much, will be the one that is plotted here. So you can see that these boxes now get clamped. And by the way, this is the torch.clone that we use right here. And the reason for that is, well, this variable is being overwritten. So in order to be able to save those variables, we have to clone it. Otherwise, it would be overwritten. So this is for display purposes. Torch.clone and the torch.clamp. Well, we want to make sure that our boxes are between a minimum and a maximum. And in this case, for our input, we want to make sure that we are between 0 and our max for that dimension. So in this case, we want to make sure that our box here for the x component is between 0 and 1024 for both coordinates. And for y, we want to make sure that our box coordinates are between 0 and 768. So this is what this is actually doing. In our case, given that they are within that range, nothing is going to change. These are our values. Here we're going to do the round. Box 0, right here. This box, box 1 and box 2, if we plot that, then what we've done is we have scaled the bounding box from this 640 by 640 to this other size image, and then scale that back to basically our input image. And we do that by performing these mathematical operations, but basically just understanding the dimensions and play with those a little bit. So this is our result for that scale, and this is what is going to be sent back. So let's continue in our VS Code. So basically, we're going to do the same here as well. Our gain will be 0.625. and then we'll calculate the padding as we did in our YOLOv environment. 0 on the width dimension and 80 on the height dimension for each side. Then we'll subtract the padding for x, which is 0, and then subtract 80 as we did. And then we divide that to convert that from the middle one, convert it from here. Now we want to convert it to this one. So they're doing it everything in one pass, but I wanted to add this helper function and visualize it a little bit more so that you see the intermediate step, which in VS Code is kind of hidden, that conversion, but this actually was happening. So we'll do that as well. And then we'll jump to this other function, clip boxes, also within general.py. Given that our boxes are a tensor, then again, this operation is the same operation that we also perform here. So we just make sure that we're within that range for the width and height. And then we'll return, and then we'll run that, and then we'll return boxes to where we call it from. And you can see that in addition to this, we're just running it. So our detect now has these values, 146, 288, which are the same that we see here. They're not rounded yet, but when I run this, now you can see that they're rounded. Okay, so hopefully that was clear. Apologize if it wasn't 100% clear, the gain. You might have to play with it a little bit to gain that intuition, that understanding, but basically we're just playing with the ratios of the dimensions.